Okay, so what I wanted to do was go over a few homework problems and to just help you out where you might be, where I'm thinking you might have had some difficulty. First thing I want to do is show you something on your calculator. Um, so hang on, let me resize this just a second. Okay, so you've seen some problems where they have like this, degrees, minutes, seconds. Here, maybe I need to use my pen, maybe. Okay, the degrees, minutes, seconds. And to be able to convert that, so I want to show you how to get that. This is number 69 in the book from the homework. So if you want to get this, what you do is you press the button between the 9 and the book. So if you press that button, right here, you see like a little box with a degree, a little box with one tick mark that stands for minutes, and another little box with two tick marks that stands for seconds. So if you click on that, then you can enter in 85 degrees, 18 minutes, 30 seconds. And if you hit enter, the answer you're given is in radians. Now my calculator is default radians. So anytime I'm doing an angle, calculating an angle, it's going to give me my answer in radians. If I want to convert that to degrees, here's how I do it. I do control book. And now this is a scroll thing. So depending on where your calculator is, you might be, down here farther. But if you scroll all the way to the top, you see you've got that arrow. Click that arrow and then type in DD, and that will convert it to degrees when you hit enter. So 85 degrees, 18 minutes and 30 seconds is 85.3083 degrees. Now what you could do is you could convert. There's 60 minutes in a degree and there's 60 seconds in a minute, just kind of like a clock. So you could do the conversion that way as well, but I think the calculator is easy. So again, you hit the button next to the book to get those three little boxes to enter in. And then if you want to convert your answer to degrees, you do control book and get the arrow and then do arrow DD, and that will convert to degrees. Okay, so that was just a little calculate. Oh, also if you want to change what setting, if you go home and you go to settings, document settings, here's where you can change from radian to degree. I personally just leave mine in radians. If you do want to change it to degrees, if you don't make it default, then it'll keep going back to radians. So if you want to keep it in degrees, make it default and then hit OK. But again, I prefer mine in radians. Okay, so that was some calculator stuff. Now I want to go back and do some more kind of homework problems. So I'm going to start with number 105. And maybe I'll just tell you which ones I was planning on doing. I was planning on doing 105, 107, 109, and 111. So if you don't need any help on any of those, you can quit the video. Or if you only need help on 109, you can fast forward a little bit, etc. Okay, so we're going to start on 105. Okay, an electric hoist is used to lift a piece of equipment 2 feet. And there's a diagram right above it. The diameter of the drum of the hoist is 10 inches. Okay, so the drum of the hoist is a circle, and they are telling us that the diameter is 10 inches. Find the number of degrees through which the drum must rotate. So it's got to lift it 2 feet. And hang on just a second. It's got to lift it 2 feet, but our diameter is in inches, so really it has to lift it 24 inches. Now this is rotating around, so we have to figure out how many angles, what angle it is that it has to rotate at. This circle has to turn in order to lift something 2 feet. So really what we're looking at is our arc length formula. And what would be the arc length if this thing has to rotate around in order to lift 2 feet? I don't know if you want to just imagine like there's a chain or a rope, and as it's rotating around, the chain or the rope is kind of like this, like the chain or the rope is lying around the circle, maybe, if you want to think of it that way. So I don't know, like maybe here's the chain, something like that. Well, that is the 24 inches. So that goes here. And then the radius, well, if the diameter is 10 inches, the radius would be 5 inches. And we want to find the angle. So all we have to do is 24 divided by 5. And that will give us our angle in radians. Okay, so let's go back to the calculator. If we do 24 divided by 5, whoops, 24, I want the decimal. Okay, 4.8, so it's 4.8 radians. Okay, 4.8 radians. If I want to convert that into degrees, remember how we multiply by 180 divided by pi? So if I multiply by 180 divided by pi, oops, and you can get pi a bunch of different places on your calculator, but that's just one place to get it. Okay, 275.02 degrees. Make sure you put that degree symbol on there. Okay, the next one we're going to do is 107. A satellite in a circular orbit 1,250 kilometers above Earth makes one complete revolution every 110 minutes. What is the linear speed? Assume that Earth is a sphere of radius 6,400 kilometers. Okay, now my drawing is not going to be wonderful, but here's Earth with a radius of 6,400 kilometers. I know that looks like a 9. I'll rewrite it. 6,400 kilometers. Okay, and now we've got a satellite that's going to rotate around the Earth, and the satellite is 1,250 kilometers above Earth. Okay, so that's going to be rotating around Earth. Whoa, terrible drawing. Okay, but you get the general idea. All right. Now we are supposed to find the linear speed. Okay, so I think in this problem it would make sense to find kilometers per minute. Since they give us that it makes one complete revolution, in 110 minutes. Okay, now we need to figure out how many kilometers there are in one revolution. So if revolution was on top, revolution goes on bottom, we're going to figure out how many kilometers there are in one revolution. So one time around the circle, how many kilometers? That's the circumference. Circumference equals 2 pi r. So in this case, it would be 2 times pi times, what's this radius now? What's 6,400 plus 1,250? That's our new radius that we're using. That's 7,650. So that goes here. That's our circumference. So there's 2 times pi. I need to erase so I have room. 2 times pi times 7,650 kilometers per one revolution. So revolutions cancel. And then now in your calculator, do 2 times pi times 7,650 divided by 110, and you'll get 436.97 kilometers per minute. Okay, next one. 109. I'm probably going to have 2 videos. I definitely will, because these things only record for 15 minutes at a time. So I'll get as far into 109 as I can, and then I'll go on to the second video. Okay, so this is the blade on a saw with a diameter of 7.5 inches. Okay, so the diameter is 7.5 inches. And it rotates at 2,400 revolutions per minute. That's what I'm going to start with. And for part A, we're supposed to find the angular speed in radians per second. Okay, so we're going to just start with our conversions. Take what you're given. Now we need to get it into seconds, so cancel out the minutes. There's 60 seconds in 1 minute, so the minutes are gone. And now we need to get radians from revolutions. Well, how many radians are there in one revolution? If revolutions were on top, revolutions go on bottom. How many radians are there in one revolution, one time around a circle? There's 2 pi radians. So we multiply across the top, 2,400 times 2 pi, that's 4,800 pi, divided by 60. And divide that, you get 80 pi, and it's radians per second. So that's part A. Part B, we're supposed to find the linear speed in feet per second. Okay, so again, I'm going to start with what we were given, revolutions per minute, and I needed to get into seconds, so if minutes were on the bottom, then minutes go on the top. 60 seconds in 1 minute. I forgot over here to cancel out the revolutions. See how you have radians per second? Okay, back down here. So minutes cancel. I need to figure out how many feet there are in one revolution. If revolutions were on top, revolutions go on bottom. How many feet are there in one revolution? Well, look at the diameter. The diameter is in inches, so maybe we should figure out how many inches there are in one revolution. Okay, so how many inches there are one time around the circle, that's circumference. Circumference equals 2 times pi times the radius. Well, 2 times the radius is the diameter. 2 times the radius is the diameter. So I could just do pi times the diameter. So in this case, it would be pi times 7.5 inches. That's how many inches there are. Pi times 7.5 inches in one revolution. Revolutions are gone now. I want to get it into feet. So if inches were on top, inches go on the bottom. So there are 12 inches in 1 foot. Inches are gone. Now I have feet per second. So now I have to multiply across the top. So 2400 times pi times 7.5